Hello, everyone. I hope you all have a wonderful semester break. Welcome to the spring 2026 semester, and welcome to this course, Principles of Electrical Engineering 2. Kind of a very interesting course, which is we are going to kind of piggyback on the previous prerequisite of this course, Principles of Electrical Engineering 1. So I hope that you have had a great time in that course, and we're going to borrow a lot of concepts from there as well and build upon that. So in this kind of a lecture zero, I'm going to kind of very briefly in 10 to 15 minutes talk about the overview of the course, the logistics, the format, and the grading. Okay, so let's get started. My name is Omar Hassan. I'm an associate professor in the department. Here's my office. In case I'm in person in some of the days, I would love to meet you in person as well. Feel free to send me an email, set this email address. This is an interesting section. This will be an asynchronous section. This was made for a variety of reasons, which we can go maybe some other time. Um, Having said that, we have a big section which is in person, and this kind of a smaller section which is asynchronous. However, rest assured, the kind of the contents that we are going to cover in both the sections will be very similar, if not the same. We are following the same textbooks. A lot of your assessments are going to be very similar as well. Um, in terms of my office hours, I will get back to you with a specific office hours every week. In the meantime, please always feel free to send me an email. Right, just send me an email, and I would be more than happy to schedule a one-on-one meeting with you to discuss any of the concepts that you are struggling with, or if you need any help with. Similarly, if there is any office hours for the TA, I will get back to you on that one as well. So just wait for the notification on Canvas. That should be coming up very soon as well. Feel free to, again, important thing is over here. Here's my email address. So whenever you have to send me an email, send me an email at this address. Uh, there is another Scarlet Mail address that I never see, so please don't send that over there. Um, okay, so moving on. This is again kind of a very interesting course, Principles of Electrical Engineering 2. Here is a list of the brief topics that we're going to talk about in the course. I hope by now you have a pretty good understanding after taking the prerequisite of this PE1 course, a very good understanding of what a resistor is, what a capacitor is, inductor is. Having said that, in today's lecture, I will give you a quick recap of those basic concepts like Ohm's law, Kirchhoff's current voltage laws, the voltage current divider rules, and what an inductor capacitor is. But that's pretty much it. And then starting next lecture, we are definitely going to move on to the very key topics that we're going to talk about in this course. So in this course, some of the topics that we will cover would be we are going to connect a resistor and a capacitor together and make an RC circuit. We're going to connect a resistor and an inductor together and make an RL circuit. And we are going to see what happens when we connect a source, a voltage or a current source to it. And what would happen if we switch it off or take that source away from the circuit. We will realize that once we are solving those circuits, that those circuits comes out to become a differential equation. If you just have one of these elements, a resistor, a capacitor, or an inductor, it is going to come out to be a first order differential equations. We will also cover some of the circuits where we are going to have capacitor and an inductor in the same circuit, maybe in the series or the parallel format. And this is going to become even a higher order differential equations, the second order differential equations. And then we are going to solve some of those equations as well. Um, this is a heavy maths course. I guess the whole electrical engineering is. So please don't run away from maths. Maths is good, important. Yeah, you won't be able to get away from that. So learn maths. Um, Anyhow, coming back, right? So we are going to talk a lot about, spend a fair amount of time in talking about RC/RL circuits, and RLC circuits, and what their responses are. We are going to cover a lot on the frequency response as well, right? So you must know by now the time domain signals that we see in real life. There's an entire universe out there, not the other universe, but in terms of mathematics, there's an entirely another transform out there which is called as a frequency transform or a frequency response. So every time domain signals, with some caveats, can potentially be represented in the frequency domains, and we are going to learn so much amazing things about it. We will realize that how we can understand those frequency principles and build different circuits, and how do they translate into our circuit elements. For example, if you build an RC circuit or an RL circuit, how what would be their time domain response or a frequency domain response. We will build filtered circuits as well. Again, one of the key objectives why we make electric circuits, and you're going to build some more noise amplifier circuits in the next electronic devices course as well. But introducing some of the preliminary concepts in this course, the filter circuits, the whole idea is to remove noise, right? And that noise can be categorized in form of a time domain or a frequency domain. We're going to talk about that. But we are going to spend a fair amount of time in discussing about how to develop these filter circuits. We will discuss another important thing which is called as the Laplace transformation. Laplace transformation, for at least to a couple of weeks. This is another way that we can represent the electric circuits, and we will realize that how useful it is in terms of simplifying some of these electric circuit analyses. So yeah, more on that. And then we are also going to have a chapter on, for example, a 4-year series. 4-year series is again a way you can represent the time domain signals into the frequency domain. But a lot of interesting topics that we will cover. You're going to learn a lot of interesting techniques. These are very fundamental techniques, and you are going to build on these techniques to do the next courses on electronic devices and then digital electronics. These are some of the fundamental techniques that you are going to leverage throughout your life, especially if you're going to work eventually in the areas of electronics, analog electronics, or digital electronics, or even embedded systems. To a certain level, microfabrication, depending on the end application as well. ASIC circuits, or yeah. So please pay attention. Okay, so we're moving on. This is a textbooks that we will follow. This is Electric Circuits. It is by Nielsen and Riedel. We are going to use a 12th edition of this textbook. There is another interesting thing that the Pearson provides, which is called as a Access Pearson. We will set up a Access Pearson tab on your Canvas page, and essentially you are going to do some of your homework assignments there, which is normally they call it like mastering engineering. So you're going to have this kind of a capability built in on your Canvas to do some of these homeworks. So if you don't understand what I'm saying right now, don't worry about it. I will send a detailed notification on Canvas on how to do that homework, how to access it, or how to set this up if it is not available on your end. So please stay tuned. But this is coming back to the book, the textbook as well. This is a great textbook. I hope you're going to enjoy it. We are going to cover most of the details from the textbook. One thing that I normally say to my students in my courses, if you go through the textbook and make sure that you are paying attention in my lectures and everything, you're going to do well in the exams and in your overall grade. So please pay attention to the lectures. Whatever the recorded lectures I am going to record, I will send those lectures, of course, in the recorded format on Canvas, and also the slides as well. In terms of these video recorded lectures, I will upload them on the box drive, so you can directly watch it from Rutgers box drive, access it from there. I am currently figuring out a way, if I can just upload it on the YouTube as well, if that can give you a slightly better access in case if there's any. In the past, there has been some problems where the students run into buffering issues with the Rutgers box, but the videos should be available in both of those platforms, the Rutgers box and the YouTube as well, hopefully. So I will stay tuned for an email over there. But you should be provided with both a video recorded lecture and also the slides. Again, important thing, please pay attention on the lectures, please review the book, and understand the fundamentals. I'm going to spend a lot of time in teaching you fundamentals. I will love that you should be able to solve the circuits, but you need to understand what what is actually going behind the circuit, right? How to solve that circuit, not from a problem perspective, right? You have a kind of a end chapter problem perspective. Understand the fundamental concepts, the observations, the yeah, what is happening in that circuit. So we're going to spend a lot of time in terms of that. We're going to spend a lot of time in mathematically driving the expressions, right? Mathematically driving an expression. So taking an expression to solve a problem is one thing, but mathematically driving an expression is going to walk you down on how to come up with a solution if you were to see a circuit that you don't know what to do with. So yeah, we're gonna learn a lot from that perspective. Okay, moving on. Here is kind of a slightly more detailed overview of what chapters we will cover directly from the book. We won't cover like the full chapters, but yeah, parts of the chapters. The first lecture, other than this overview, I'm gonna upload another video recorded lecture on the where I'm going to again provide a quick recap of the basic circuit elements, which will be a resistor, inductor, and a capacitor. Then we are going to spend at least another couple of weeks talking about the first order circuits from chapter number 7, another 1.5 to 2 weeks on chapter number 8, where essentially first order circuits are your RC and RL circuits, and second order circuits are where you have both of these energy storing elements, inductor and a capacitor, with a resistor in the circuit. So we're gonna spend some fair amount of time over there, and then we are going to spend another like 2.5 weeks on Laplace transformation and circuit analysis. We are going to do this Bode plots and learn about the frequency response as well that I was talking about previously. Then we are going to make filter circuits in chapter number 14 and 15. Then we are also going to talk about Fourier series and two-port networks. So we will see. I hope to cover as much details as possible in these lectures and throughout the semester. Yeah, well, the one thing that I always run into, I want to teach you more compared to the time that I have. So yeah, let's try our best on how much how many topics that we can go through. So we'll see. Okay. Here is a tentative plan of what we will cover in each lecture. Again, consider this to be tentative. So for example, our lecture number 1 is just intro and the review, and in the second lecture we're going to kind of start with lecture number 2, and we are going to talk about the first differential equation. This is the first order differential equation, not the first differential equation, and essentially this is coming from if you just have a circuit which is just an RL or an RC circuit. Anyhow, coming back, what I will do is I will make sure that you will have those specific lecture slides available by the date written over here, if not earlier. Again, in most of the days I will try to provide you those slides a day earlier than the date written over here on the schedule, or at least on the same day if I'm running into some any delays. Every now and then I do have some buffer lectures, and we will see how to use that buffer lecture. Maybe we can cover more additional details or a review of the prior materials. So we will see. But this kind of gives you a nice overview of throughout the semester course contents that we are going to cover. Here's another good reference book, Circuit Analysis and Design. You are more than welcome to review this book as well. It's a nice book, second edition of this book. This is available to download for free from University of Michigan website. I think this link should be working. The last time I was sent this link by someone seems to be working, but do cross check. Having said that, again, I would highly recommend reviewing this book as well. but at the same time, I do want to emphasize on this fact that please pay special attention to my lectures, and as long as you are covering the materials that is being covered in the lectures, you should be okay to do in terms of all the assessments, right? So, for example, I don't want to assess you. I want to assess you on the things that I will teach you. So that's my underlying principle. So, pay attention to the lectures. Okay, moving on. Here is the overall tentative grading policy. And the details of the what your assessments are going to look like. There will be 10 homeworks. They are all available on Canvas, and the Access Pearson thing that I was talking about in the earlier slides. So you will receive an official announcement and how to implement that and how to do this. But these will all be done over Canvas, and all of them will be auto graded too. So we're going to talk more about that, how this will be done. All of these 10 homeworks will be auto graded. You're going to receive a grade automatically on Canvas. So we're going to talk more about that, how to set this up and how you can do these homeworks automatically on Canvas. There will be two projects, 15% total. For example, one could be 5%, another one could be 10%, or 7.5% both, but the total will be around 15%, if not exactly 15%. Again, both of them needs to be submitted over Canvas as well. Both of these assessments will be exactly similar in between the two sections, your asynchronous section and the other one in-person section. The one thing that will be different would be these Canvas quizzes. I will take 4 on Canvas quizzes, 20% total, which is 5% times 4. I will take those 4 Canvas quizzes and they will be with some sort of a proctoring enabled and a lockdown browser enabled on Canvas. And I am currently figuring out what the format of those quizzes will be. I will get back to you when those quizzes will be. At least I will give you at least a 1 week heads up of when your quiz is going to be. So prepare for the quiz. It is going to be on Canvas. The next two items in terms of your assessments, there will be one midterm 20% and there will be one final 25%. Both of these will be currently, consider this to be tentative, but both of these assessments, midterm and a final, will is currently, we are currently considering and planning to do this thing in person exactly at the same time as the other section, not the same place but the same time. So if this will be done on a Monday, on a Tuesday morning or a Friday morning, we will see and we will get back to you where it will be done and when it will be done. But it will be done exactly at the same time the other section is taking the midterm and the final, and this is to ensure that all of you are receiving the assessments at the kind of the very similar assessments and not that drastically different assessment and or the grades. But this is kind of still tentative and I will get back to you. In terms of the final grade, I don't usually I don't kind of scale the grades. Having said that, I don't put the certain thresholds on the grade right away. For example, at the start of the semester, I won't say that okay, 90% above is going to be an A grade. It may come out to be a 92%, or it may come out to be an 88%, or an 87%. So final grades will be done based on some thresholds, and those threshold selections will be done based on how the entire section is performing in most of these assessments. But the grading that will be assigned and the grading scheme that will be assigned to our asynchronous section will be different as compared to the in-person section. So our section is going to have an entirely different grading scheme, and all of you are going to receive grades separately as compared to the in-person sections. We're not going to have exactly the same. It will be graded the same way. And again, in my case, I will select the thresholds towards the end, and of course, I will let you know what those thresholds are going to come out to be. Some general thoughts and kind of important points to consider. Again, I will provide lectures, video recorded lectures, and slides on every Tuesday and Thursdays every week, right? I will try to upload these slides even a day in advance but tentatively, in terms of scheduling, um, just consider that those will be available on Tuesdays and Thursdays. Please make sure to review these lecture contents as I have been emphasizing throughout this introductory video. And after you do that, please feel free to send me an email if you need any help. You can utilize my or my TA's office hours. There are three ways you can do this thing. One, if you have any questions, right? Reach. I will let you know the TA office hours and or the TA contact information as well, whom to contact for questions. So you can directly contact the TA or come and stop by the TA office hours. Second, if I will assign my fixed office hours, please come to my fixed office hours with any questions that you have. Third option, you can just send me an email with a question and I will be more than happy to reply back to that question over the email. Fourth, you can send me an email and I will be more than happy to schedule a one-to-one meeting. My off If I will have a dedicated office hours, then one-to-one meetings separately may not be possible. Then we are just going to be kind of fixed with the fixed office hours. However, if I will not have fixed office hours, then I will be happy to schedule whenever you guys need one-on-one a meeting as well. Having said that, feel free to send me an email anytime in either case, whether fixed office hours or as needed office hours. Send me an email, and I will be more than happy to respond back with any questions that you have. We already talked about this, right? So the quizzes, assignments, and the projects will be submitted on Canvas. Midterm and the final is tentatively in person at the same time and the date as the other section. And then we talked about the two projects, which will be 15% total, and they needs to be submitted on Canvas. The projects and the homeworks will be exactly the same as in between both sections. Here are some other rules, important rules. There will be no makeup exam and or quizzes and or changes in the timeline. Right, so there won't be any changes in the deadlines except for, of course, the medical reasons, jury duty, or if there's any other special circumstances. Those special circumstances, mostly medical, needs to be verifiable and documented, right? So please provide those things in advance. And again, if you have any questions, feel free to send me an email. The entire syllabus that I talked about and the grading scheme is tentative and subject to change. Of course, we want to say that in case we would change something. But having said that, yeah, there's a very good chance that this will pretty much the same. And in terms of there's going to be a separate Canvas page for all of you who are taking the lab section as well, and most of the lab announcements will be coming directly on that page. So stay tuned on the announcements on that page. And just kind of a quick comment on the lab, there will be no lab the first 3 weeks of this course. But having said that, right, all the relevant announcements related to the lab, you should be receiving that on the other Canvas page. So with that, thank you so much. And I will talk to you in the next lecture. Thanks. Bye bye.